Hey everyone, welcome to another BTM screencast. Today we're going to be looking at Chapter 34, Wood Frame Construction. So some of the types of framing construction that we're going to go over are platform framing, balloon framing, and post and beam framing. So first we're going to go over the differences between platform framing and balloon framing. So on the left, this is our typical platform framing. So we start with the foundation, we have our sill, and then we have our first platform. On top of this platform, we have our stud walls coming up, double top plate. Then on top of that, we have another platform. From that platform, we have our stud walls again. And in this case, we're ending right here. There's our rafters for our roof. Now when we look at, on the right, the platform framing, it's similar that we start with the foundation and we also have stud walls, but this time our stud walls come all the way up to the top. So they don't stop. It's not more modular like platform framing, but our studs run from top to the bottom, bottom to the top. Instead of having a platform for our floor to sit on, or I'm sorry, our walls to sit on, we have a ribbon that runs around. It's usually a 1x4, and on top of that is where our floor joists go. In this one you can see that there's fire stop, and we're going to be going over what that is shortly. And we also have fire stop over here. Fire stops are material installed to slow movement of fire and smoke. It doesn't stop fire and smoke, but it slows it down. Fire stops must be installed in the following: stud walls, partitions, and any spaces that are furred, between stair stringers, also around chimneys, fireplaces, vents, and pipes, and any space between floor joists above girders. Generally, fire stops will go and they prevent fire and smoke going from room to room or floor to floor. Here's some examples of fire stops that we have. Up here you can see that this is in a stud wall. Here's our fire stop right here. Another example for a stud wall, a fire stop right here. In this example, here's a vent or a pipe coming through. It looks to be a 2x6 wall. And you can see that this is notched out completely. So we want to stop the smoke and the fire from spreading as fast. Here we have a floor joist next to a chimney. We can't fasten the floor joist to the chimney, but we can put a piece of non-combustible material in here for a fire stop. Here's our example for the stairs. Now this allows smoke and fire to come up between the floors, and having a fire stop here and fire stop up here will help slow that down. Post and beam construction, this is the third one that we mentioned earlier. It uses fewer but larger pieces. They use large widely spaced timbers for joists, posts, and rafters. Matched boards are used for floors and roof sheathing, which we'll be seeing in a second. And the walls are sometimes stud framed between the posts. So here's an example of post and beam construction. You can see that we have our posts coming up. We have our ridge beam running up through the center. Common rafters cut for the roof beams. And this is your structural wood plank for the roof. And we also have the same for the floor down here. Here's two different versions of post and beam construction. So on this one, we have our ridge beam, and then we have our transverse roof beams coming down. In this example, we have longitudinal post and beam construction. So they just run front to back, the length of the building. And again, here's our roof plank, and then our floor would be the same. On this one, our floor plank is run this way. So here's a conventionally framed wall in between two posts. So you can see here we have our king, jack, header, double top plate, or diagonal brace. Sometimes these stay in place, sometimes they don't. Post, post. So this allows us to put a nice door opening in where we need it between two posts. Then we're going to go over some green framing methods, and these help save material and save money. One way to do it is use a single layer of 3/4 inch tongue and groove plywood or OSB over the joists instead of the wood that we talked about previously in the post and beam construction. Walls can use a single layer of plywood. Generally, for this, you use 1/2 inch plywood. And if we design houses with widths that are evenly divisible by 4, this helps save material because most of the material that we have falls on 4-foot centers. So in continuing with saving costs, roofs can be modified to improve insulation over the exterior walls. And so you can see here, we're able to insulate the entire width of the house. And what that does is it creates a barrier and it increases the efficiency of the house by not allowing cool air or hot air in, depending on the time of year, or slowing it down. So if you're able to insulate here and here, and you want to keep your house nice and cool in the summer by having insulation going across the top, it allows for less of the cool air to escape and less of the hot air to get in. More green framing methods to save more costs while building. Sizing and locating windows and doors to fit on-center studs saves material. Well, what's that look like? So in this example, on this side, we have the window. Again, we're talking about on module, so everything's laid out. So we can see here, in this example, we have 3 studs. We have 2 jacks, and we have 3 cripples. So 1 stud, 2 stud, 3 stud. Our cripples, 1, 2, and 3, and our jacks, 1 and 2. Now, if we don't lay out for that to happen, like on the right, then you can see that we end up having 1 stud here, king stud, another stud. That gives us 4. Then we also have our jacks going up to the header. That gives us 2. And we have more cripples also. 1 cripple there. We need to continue our 16-inch centers from here to here. So we need 1 here, another 1 here, and we also need another cripple to go right here. So just by not laying it out, you can see that 23% more framing is required. That's an increase in cost and an increase in time. So the sizing of structural members in a house are typically determined by engineers. And this goes for many projects, not just houses. For this module, we'll be focusing on girders. And girders are the main structural support that supports the floor joists. So in addition to the wall, if you have a span, that's determined that you need a girder, then your joists lay on top of your girder. The size and type of the joist materials may be determined from building codes like the International Residential Code. So codes define span limits of joists using terms and numbers. They have joist spacing. Generally, this is 16-inch on center. It could change depending on the requirements of the floor. The joint span, same thing, that could change depending on the requirements of the floor. The material strength, that depends on the requirements of the floor. And all of those are determined by the intended load. So the live load is what's expected to be on there when someone's in there. So if you have a building that's going to have, it's expected to hold 80 people all the time, the requirements are going to be different than your house. Your dead load is just the weight of the building materials. It's also known as a static load. So here's a quick list of floor joist spacing for common and engineered lumber. It's letting you know where they need to be, and it also lets you know the type of lumber that you'll be using. So if you use 2x8, 2x10, 2x12, and then over here is the same. And then you can see for the different types, this is Douglas fir, and this is letting you know under this one, the maximum span is 14.5 with a 12-inch or 1 foot spacing. When we go to a 16-inch spacing, you can see that the Douglas fir comes down to 13.1. So this chart, it's nice to know to be able to find the stuff, but most of that will be done for you by an architect or an engineer. So for girder and header span charts, again, they're depending on the expected load. Typical roof load changes from one region to another depending on water, and it also depends on the type of roof. So if you're going to have a lot of water, or if you're going to have a lot of snow, all those play in to the type of roof load that you would have. Joist length also affects girder load. So here we go with some girder and header spans for exterior load-bearing walls. You can look that over. Again, this is going to be more useful for an architect or an engineer. In conclusion, the framing styles may vary. Again, those are platform, balloon, and post and beam. Fire stops are essential for a safe building. While they won't stop the fire, they will help slow it down. Green building techniques can save material, they can save money, and they can save time.